it's best to start now. It's 10 minutes past our time, so it's enough time we have given everyone to join. Anyone who is not here, it means he or she is not ready for the class today. All right, so today we're going to start something quite interesting. Or throughout the course of this boot camp, you guys have been building on and learning about multiple blockchains, from EVM down to or let's say from Ethereum itself, which is like the father of all blockchains, building programmable apps, if you understand what I mean, down to building on some L2s, or also building on Zion blockchain, right? And then here we are today, building on StarkNet, which is also an EVM or a blockchain scaling Ethereum. So I will just be sharing my screen in a bit so you guys can have a glimpse of the slides, and then we'll get started. So I held a very similar session to this some weeks ago. That was for Blockfuse Labs, and it was an introductory session, which is same with this one. And I'm going to be using the same slides for the course of that. So let me just check where the slide is, and then I share my screen. All right, so can you guys see my screen?
Yeah, we can see your screen.
Awesome, awesome. All right. So in the course of today's class, we are going to be studying like the following. So these are our agenda for today. We are going to be learning why StarkNet. In the concept of understanding why StarkNet, we explain what StarkNet is, explain what Cairo is, understand what these two are, understand smart wallets, and then check out StarkNet architecture. Then we'll take the Q&A session, and then we are done for the day. Just very short itinerary to achieve. So let me pause to ask a few questions before we proceed. How has building been for us, like from the introduction of this blockchain, introduction of this bootcamp down to this current state that we are now? How has it been? Building on multiple blockchains, do you find it interesting, or do you just enjoy building on one? So if you find it interesting, let me just see your hands up, or you give me emojis. If it's not interesting, if you want to face only one, then we also know. Maybe I might convince you to make StarkNet your one and only blockchain that you are building on. All right, so quite a number. So let's get to the order of the day. Why StarkNet? And then before why StarkNet, we are going to be starting with why Cairo. Yeah, so I remember I didn't take this step by step or in sequence. So why Cairo first and foremost? So before we go deep, you guys should know that StarkNet is a layer 2. When they say layer 2, it simply means that the blockchain or every blockchain faces a particular problem, which is commonly known as the trilemma problem. So the trilemma problem is a problem whereby one single blockchain cannot have three major features or all the three characteristics of a blockchain. So the characteristics of a blockchain include the following. So we have scalability, decentralization, and then security. So these are the three. So for you to call something, or for you to call, for something to be said to be decentralized or to be a blockchain, it must have like these three main features: security, decentralization, and scalability. But then this has been like a myth for a while. So there hasn't been any blockchain who has been able to implement these three. So it's either a blockchain is decentralized, or it's not secured, and it's also scalable, or it is decentralized, it is secured, but it is not scalable, or it is scalable, it is decentralized, but it is not secure. So that has been the problem. Just like the common word that they say, human being, you can't have it all, right? That's the same thing as the trilemma problem. The problem that almost every blockchain faces. So as you guys all know from the introduction of this bootcamp, I took you guys on Ethereum. So we look at like a comprehensive introduction to it. And then we spoke about how Ethereum is the world's computer, right? Or the first programmable blockchain that we have. Now, Ethereum also faces the trilemma problem. But out of the three main features, Ethereum implements like the two major ones. So first and foremost, Ethereum chose to be secured and also decentralized. So decentralized in the sense that everyone has access to it, everyone can contribute to it, and everyone can add his own quota to the network. And then secured in the state that it cannot be hacked. Now my mouths are heavy to say that. So secured in the sense that the network is being shared by all, and then there are a lot of people participating in it. So that's how you know that a blockchain is truly secured, right? Or how a blockchain is security is improved by the amount of people that are participating on that particular network, and then all the different stuffs or characteristics that has. So that's just it. So what I just need you guys to know that is Ethereum is decentralized and it's also secured, but it is not scalable. It is not scalable in the sense that Ethereum can only process a very minimal number of transactions. Even as a lot of things have been improved with the recent upgrade, mostly the addition of block size but that's even for even L tools. So what you guys just need to know is that it's not scalable. Meaning, when they say something is not scalable, it means it cannot accommodate more. It has a limit that it can go. So from when Ethereum started, I think it was just able to perform just about 15 transactions per second, which you guys will agree with me that is a very, very, very poor number, in the sense that we don't have plenty of people using the blockchain now. But if eventually we have the billion users that everyone is talking about, or everyone is praying for, um, 15 transaction per second is just going to be like a drop of water in the ocean to the amount of transactions that are going to be performed. And then with this, obviously, you know that the network is going to be slow, which all of us don't want, because our Web2 system is not slow. It's working at least to the level of technology that we have in the world today. Is serving us properly. So if we bring a slower system, then the blockchain is not going to have proper adoption. So that's one thing that Ethereum faces. Ethereum is not scalable if it's just the layer one network on its own. So a lot of people now came up with the problem, hey, how can we solve this issue? Because Ethereum is open source and it's free to all, free for everyone to add up, contribute to, and make the network better. So group of people sat down, some decided to come up with L2s, which are layer 2 solutions. And then they decide to solve the problem of scalability. So now, how did they solve that? Now, solving the problem of scalability, they just built another layer of a blockchain, and then it is running on top of a layer one. So the layer one in this case is Ethereum, which offers decentralization and scalability. Then they built another solution on top of it that can bring scalability. So since three cannot be achieved, the layer twos just said, okay, why not let's work on scalability? Then let's like extend to the layer one layer, or settle on layer one that has the decentralization and scalability. So that's just what happened. And then with this, you guys are going to notice that there are a lot of blockchains springing up. You guys must have heard of Optimism, Leaks, Zion, StarkNet, and the rest of them, all of these blockchains, right? What these guys are just doing is that they are trying to offer scalability to Ethereum so that they help Ethereum to process more transactions, so that the network is going to be faster, and then it enjoys from Ethereum's security. So now that's just the explanation of what we've been doing. Now, today we are going to study about one particular one, which is StarkNet, out of all of these layer 2 solutions. That's what we are going to be introducing today. And then in StarkNet, every blockchain must have its own programming language used for writing smart contracts. So you guys all know that smart contract lives or a logic that works on the blockchain, right? Perfect. So for StarkNet, Cairo is a programming language for writing smart contracts on Cairo. So that's why, to introduce this properly, we are going to start explaining a little about the programming language. Then we head back to the blockchain itself and then understand. So let's understand why we are using the programming language before we get into building on the blockchain itself. So hope you guys are not confused and everyone is already pumped to what we are going to learn today. So let me get your emojis before I explain what Cairo is. All right, guys. So why Cairo? Why Cairo? Okay, so what is Cairo? Cairo is a programming language that is designed to leverage the power of mathematical proofs for computational integrity. Short explanation, short definition with a lot of big grammar in it. So just as C.S. Lewis defined integrity as doing the right thing, even when no one is watching. So Cairo enabled programs to prove that you've done the right computation, even when executed or on untrusted machines. All right. So this is like one of my most interesting definitions and why I choose to write Cairo much of the time. So among all the programming languages that you guys will be learning or you guys have learned, trust me, Cairo is going to be like one of the most interesting and one that you are going to find fascinating simply because of this powerful feature that it has. So in Cairo, Cairo does not just do your own computation for you behind the scenes. Or, you know, every programming language, after you finish writing the code, the logic is being broken down into the normal either assembly language or machine language so that the compiler is going to understand what is going to process at the end of the day. Now, if this computation is being done, it sends the results back to the user with the aid of the programming language, right? But then you, the developer that wrote this language, or sorry, that wrote this particular code or logic, you are just trusting the computer or you are just trusting the compiler to be able to make this computation for you and send back. You don't know whether the computation that it made is correct. Do we get the problem or why Cairo was introduced? Now, this is just it. Let me give you a short explanation. It's just like you're a mathematician, and then, you know, as a math student, if you write a mathematics exam with a calculator that's giving you wrong answers or is not making your computation correct, do you know that you are going to end up failing that exams? Even but if you punch it and then the calculator is giving you wrong computation, do you know you are already off? Only one person is agreeing to that. So we have few mathematicians here. Is it Paul? All right. So that's the same thing with the normal programming languages we write, like the JavaScript, the words that you write. You don't know whether the computation is correct or not. And then that's why a lot of people question themselves. You know, JavaScript, there was one argument where if you add, is it 2 plus maybe a string, just try to run it with JavaScript. Try to add a number plus a string and then see what you are going to get at the end of the day. Maybe you might get not a number or undefined. And then you have written your computation and you said you are waiting for the computation to give you a number back as the answer. And then the code is giving error behind the scene. And the logic, everything is working. You don't even know what's happening. Don't know that your computation is what has the error. So this is a simple problem that made them brought like Cairo. All the programming language, most of the programming languages we are writing, computations are done behind the scene by the compiler, and we don't know if these computations are correct or not. So Cairo work with mathematical proofs for computational integrity. So while you are trying to build with Cairo, as soon as it does computation for you, it also comes back, or it does not only return back the result, but it also returns back the result with a trace, which is a mathematical proof for the computational integrity to be sure that, yes, this computation was computed and it is correct. So now, imagine it's like you using your calculator, and then your calculator does not just return back your results, but as soon as it gives you back your results, it also gives you a proof that, yes, this computation is computed correctly and everything is well, good to go. Now, another use case scenario, imagine you are a developer for your country. Let's say you are working for the Nigerian Army, and then you are working there as an IT consultant, or sorry, as the software guy there. And then you guys are the ones writing the code to deploy the missiles for your rocket launchers. So let's say Nigeria is currently at war with Ghana or any other country that we always have banter with. So let's say Nigeria is having war or waging a war with Ghana, and then our code is written in Nigeria, but then the supercomputers that are going to run the computation at first, what happens within the computer is that the logic is being collected, then the supercomputers are going to translate this logic for the compiler to understand, and then the execution is being made. So imagine that these supercomputers live in Ghana. So in simple case scenario, we know that most of our supercomputers live in Europe, right? Maybe in Silicon Valley or any of these big tech giant companies. So imagine that they live within these countries, and then you are waging war against them. And then you have written your code, let's say in JavaScript or in Rust, and then you wrote the code and say, hey, I want to deploy this missile to so location, so longitude and latitude. Maybe this missile should go and get deployed or should detonate in Ghana or in US. And then these supercomputers exist in US. So the simple thing here is, after you finish writing your code, before your logic is going to get executed first, your logic will have to go to Ghana first. And then the supercomputers in Ghana will look at your logic. And then it executes whatsoever they want you told the computer to execute. So think of this. Now, what if the guys who wrote or who mounted the supercomputers in these countries decide to tamper with your logic? And then instead of them deploying the missile to Ghana, they decide to change the coordinates back to Nigeria or back to your exact place that you are. So how are you going to do it? Without computational proof, you are not going to be sure that this or what you are executing is correct. You are just working blindly. Yes. So that is why Cairo exists. So I guess that's more than enough explanation to make you want to write Cairo. All right, so what are some of the features of Cairo? So Cairo can help us create provable programs. That's the long English I've been explaining all this while. Cairo runs on top of the Cairo VM. So at first, when we were explaining Ethereum, you guys knew we're talking about like EVM, right? Which is the Ethereum virtual machine. So the Ethereum virtual machine is where this computation gets executed, right? Like the supercomputers I'm trying to explain. So, but in this case, the logic for Cairo gets executed in Cairo VM, which is a Cairo virtual machine. So the syntax is heavily inspired by Rust. So for those of you that have written Rust before, you are going to find this quite interesting. For those of you that have not written Rust, this is your best gateway to start learning Rust, because with a little bit of Cairo, you can be able to write Rust. He also implements similar ownership model with Cairo. So you guys will be learning a new concept now. For those of you who are coming from JavaScript perspective or Solidity learning point of view. Cairo is also a strongly or strictly typed language. It also works with traits and macros. Those who have worked with Rust, we understand what traits and macros are. And then Cairo can be used outside of StarkNet. Now, this is the second and most important features. Or sorry, the last and most important feature of Cairo too that I like. So, for those of you who have written Solidity, you agree with me that you can only write, or Solidity only exists on the EVM. Though I'm seeing now a lot of people are already making waves so that it doesn't exist only on the EVM. So that simply means if EVM doesn't exist, which is Ethereum virtual machine, it simply means Solidity does not exist. So as a Solidity developer, if the EVM doesn't exist, Otilo, your job don't go. But then Cairo, whether it exists, whether StarkNet blockchain exists or not, it's you can still use Cairo simply because you can use Cairo to write programs, not only smart contracts. Because you know that in Ethereum, you use Solidity for writing only smart contracts. But Cairo can be used for writing normal programs and also for smart contracts. In this main states that we are, it cannot be used for writing what's it called? Web applications. So in case you're a backend developer and you want to ask me what's up, how can we write web apps? For now, that doesn't exist. But I know that subsequently all these are going to get implemented, and then you can even use Cairo for web applications. But just know you can build your normal programs with it, just like your normal JavaScript programs you can build. All right, so all the long explanation done. Now, why StarkNet? So to the most part of today, why StarkNet? So first question, what's StarkNet? So StarkNet is a validity rollup, which is also known as a ZK rollup. It's a layer 2 network that operates on top of Ethereum. Subsequently, StarkNet is not going to be scaling only Ethereum. StarkNet is also working hand in hand to scale Bitcoin also. So it's not going to be only Ethereum. Bitcoin and then Ethereum also. So enabling dApps to massively scale without compromising on security. If you remember the long explanation I made about the trilemma problem. So it is working with Ethereum because Ethereum is fully secured. And then StarkNet is offering the scalability with the help of the validity rollup, as a validity rollup, sorry. So how does StarkNet achieve scalability? StarkNet achieves this by bundling transactions into off-chain computed stack proof. Now, don't get stack proofs. You are going to be understanding what they are, but don't get too bothered. So this proof is then submitted to Ethereum as a single transaction, resulting in significant higher throughput, faster processing times, and much lower cost, all while retaining robust security of the Ethereum settlement layer. All right. So now, I told you guys Ethereum is slow, right? Here's why it is. Here's why Ethereum is slow. So you guys all know that the blockchain is just a combination of blocks, right, being chained together, and these blocks contain transactions. Anyone that doesn't understand that should go back to the first introduction to blockchain and make sure you understand that. So now these blocks are then being verified. So these blocks is then being validated before it gets added to the blockchain, right? So in Ethereum, if a validator validates one particular block or produces a block and changes the state of the blockchain, let's say the new state is 42, he has to wait for other validators to also go through the same process of validating this same thing again. So that's why the network is slow, simply because when one update is done, every single validator has to validate it to be sure that yes, the network is correct, everything is good to go. And then with this, it makes the network lag simply because for every transaction, the validators have to go through the same process before another state can be updated again. And that's what's making the network slow. Or this is the layer one scaling problem. So this is how StarkNet is solving this. So in StarkNet, when a new state is being updated or a validator has validated a particular state, you know, I told you guys when building with Cairo, first and foremost, you need Cairo after it returns a particular result, or after you give it a computation to do, and then it returns the result of the computation for you. It also gives you a proof that this is, or this computation is valid. And then that proof is very, very minimal. It doesn't take anything to be able to validate that that proof is correct. The power, the computational power used to validate that is very, very minimal. So if StarkNet gives you the new state and also gives you back a new proof, here is what the validators do. The validators don't have to validate like this, the whole information again to be sure that everything is correct. All they just have to do is validate the proof. And then, like I said, the cost of validating the proof or the energy to validate this proof is very, very minimal. It doesn't take anything at all. So with this, it has reduced the time in order to validate these particular transactions. So instead of the validator validating like this last chunk of information, all you just have to do is validate only the proof, and then we are good to go. So execute once, verify everywhere. Okay, so now why StarkNet? Higher throughput, faster processing time, meaning transactions are processed much more faster. In simple explanation, Ethereum, I told you guys 15 transactions per second, and I explained why it's slow. But on StarkNet now, which is a scaling solution, it doesn't have to. What they do is they bundle thousands of transactions together, a bunch of transactions, and then they send it to Ethereum as one. So instead of Ethereum, instead of we running this transaction one after the other 1,000 times in Ethereum, we run these transactions on StarkNet so that because it's quite faster, very faster. And then StarkNet is going to aggregate this and then bundle them, generate a proof, validate it, and then send it to the layer one, which is Ethereum. And then Ethereum is going to secure it for us to be sure that everything worked perfectly. So that's the faster processing time. So instead of we taking 15 seconds, we can now take 2 seconds or 1 second, which is much more better, right? Imagine instead of we running 15 transactions per second, we are running 1,000, we are running 5,000, we are running 10,000 per second. Now that's like, even though it's not, let's say, what we might be needing subsequently, because we might need like much more better transaction. But for now, it is solving the problem and also for later times that are coming. So we also have much lower costs simply because in Ethereum, because it takes slower time to, because it takes lesser time to run the transactions, and then we need gas. And then you guys must have heard about priority fee in Ethereum. So you need, the longer it takes to process much transaction on a network, the much expensive it's going to be to run a transaction on it, simply because the network is slow, and then the priority fee fit in. So the validators are only prioritizing people with higher transaction fees. So if your transaction fees are low, you're not going to get, your transaction is not going to get passed through, right? Or validated. But in the case of StarkNet, and in the case of scaling, much more transactions can be processed, so there's no need of charging more. And then simply because we are bundling thousands of transactions and making them one, so instead of paying for the cost of 1,000, we are going to be paying for the cost of just one, and then sharing it among the remaining 1,000 people. So imagine instead of paying $1 for one transactions, you pay $1 for 1,000 transactions. So you see, that's much more cheaper, right? Now, next, native account abstraction. For those of you coming from Ethereum point of view also, a lot of people are tired with the normal, what is it called? A lot of people are tired with the normal EOAs where you have to store your private keys, blah, 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 all those long story, creating a wallet, storing your seed phrase, private key, trying to sign a transaction, and all those long talk. So a lot of people are tired of that. And then currently on StarkNet, native account abstraction is being implemented, whereby every account is a smart contract. Now, this is it. With the work of EOAs, you all know that EOAs work with a lot of hashes, a lot of hashing algorithms to be able to create all those your keys so that they are going to be secured for you. But there's a problem. All this hashing algorithm, with time, with the introduction of quantum computers, this hashing algorithm can get bypassed. And with that, our wallets can get compromised, even without someone having our seed phrase or our private keys. So those hashing algorithms, they are more sophisticated, way beyond just normal human interactions or human bypassing. But with the introduction of quantum computers, trust me, this can get bypassed. And then this was written in a blog by Vitalik himself. So a lot of research has been done about this, and then they have realized that, hey, if we continue working with normal UAs, there is going to be a problem in the long run. So with native account abstraction, whereby every account is a smart account, which simply means every account is a smart contract. So in Ethereum, you know that we have two different accounts, right? EOAs and contract accounts. So the contract account work with code, while the EOAs work with the private keys. So now, in StarkNet, we are eliminating EOAs. So no need of private keys, no need of these hashing algorithms. What we are working with is code. So your wallet exists as a piece of code which exists on the blockchain also. Now that makes it much more secure. And then quantum computers cannot get past that because it doesn't implement any hashing algorithm to save your keys for interaction. Hope we are clear. A lot of long English. Let me see emojis to be sure I'm not talking to myself. Ha. So lastly, we also have native upgradability. So native upgradability, for those of you who have been building on Solidity, you are going to understand what I mean by upgradability. So in the first place, when you guys are learning about the blockchain, remember we told you guys that, hey, once everything on the blockchain is immutable, meaning that nothing can be changed. Once it has been updated, it cannot be altered. Simply means when we deploy our logic, our smart contract, it cannot be altered, nothing can be changed. The logic is there and it exists on the blockchain forever, right? Which is a very big problem for those of you who are back-end developers in Web2. You agree with me that when you are building apps, more features can be coming in. So take, for example, your users might want more amazing features, and then you have already written the logic. So how can you have more features in the app? If it was Web2, you can easily just push to production and you are good to go. Everybody has a new update, right? But on the blockchain now, we are telling you that, hey, your contract address only exists for your contract address is just the logic that was written in it that exists inside. You can't change this logic. You can't add more logic at least. So you see, that's another problem that has been faced, right? So in StarkNet, native upgradability is being achieved. So previously in Ethereum, someone came up with a standard that tried to bypass the system. The standard is called the diamond standard, or sorry, proxy contract also. So those two can be able to work out, whereby they found a way where smart contracts can be upgraded. But trust me, it's a very long method to be able to achieve that. And it's quite cumbersome. And it is not native, meaning Imagine you trying to patch something, right? It won't work as something that will work if it was built for that. Okay. So on StarkNet with native upgradability, as a developer, you don't have to worry about all the wahala about smart contract not being changed or increasing your logic. All you just have to do is write the code, and then with the architecture being written on StarkNet, you can simply change or make upgrades to your code, and users are going to have access to it from your contract. So if you have been building on Solidity or you have been building on other blockchains before, trust me, you are going to love with these new features. I'm sure you have seen something that has convinced you to write Cairo and to also build on the StarkNet blockchain, because a lot of problems that were faced some years ago have been fixed by this blockchain natively, not with patches. All right. So enough of why StarkNet. Let's go to understanding rollups. So remember, I told you guys StarkNet is a validity rollup, right? So what are rollups? Let's understand what they are. Before that, let me just grab a drink. I think I've spent an hour here and I'm exhausted. Me too. So what are rollups? So rollup scales L1. Rollup is the same thing with the layer 2 solution, right? So if you say layer 2, they are still referred to them as a rollup. So rollup scale L1 by moving majority of the heavy computation off the base layer. So the base layer is layer 1, right? Which is Ethereum, or it can be Bitcoin or any L1 at all that has L2 on it. So instead of executing transactions one at a time on the L1, rollups execute them on a layer on top of the L1 known as L2, where it's cheaper. Then they bundle numerous transactions together into a single compressed summary and submit it to the L1 for verification. So this approach offers several advantages like cheaper transactions, faster transaction processing, enhanced functionalities, etc. So these are a simple explanation of a rollup. I think I've been saying this bulk of the time, so I won't waste much of our time trying to explain this again. So type of rollups. There are majorly two types of rollups. First, we have the optimistic rollups and then the validity rollups. So remember I told you guys there are plenty layer 2 that exist, right? And all of them are trying to scale. So for it to be a layer 2, you have to pick either of these two rollups. I don't know whether more solutions are coming in subsequently, but for now, these are the two most popular that exist: optimistic and validity. You have to pick one of these and then implement to decide which one you are. So after I explain this, we'll know where which rollup is StarkNet, what type of rollup is StarkNet. So I've already told you guys. And then with this, you can also be able to distinguish between an optimistic rollup and a validity rollup. Any rollup you see at all, you know whether it's optimistic or is a validity rollup. And then you know which one is best for you to use. So this class is not for comparisons, but let's just try to explain them. All right, so optimistic rollup. This rollup operates under the assumption that all transactions submitted to the L1 are valid by default. So that's how they operate. So to prevent fraud, they incorporate a dispute resolution mechanism that allows anyone to challenge the transaction in question with a certain time frame up to a week by submitting something known as a fraud proof, which proves that the state was incorrect. Yeah, so that's how optimistic rollups are. So you know that in every blockchain there are validators, right? Or miners. And then these guys are the ones that ensure that, hey, every transaction is being added to the blockchain. So in optimistic rollup, for every transaction you submit, it assumes that, hey, this transaction is a valid transaction. It's not a fraudulent one. And then automatically just updates it to the network. And then after that, there is a time frame, which is normally about 7 days, which is meant for dispute resolution. So anybody that comes to, or any of the validators that computes and then comes with a fraud proof to say that, hey, this transaction is not valid, then the transaction is going to get revoked and then it's going to fail on the network. Which to me, so this is just their solution. So let me explain the two solutions first, then let's look at the similarities or talk about them. So that's just how optimistic rollup works. So just know that if you perform a transaction, it gets updated, but before it gets validated and fully settled on the L1, it has to pass through a dispute resolution time frame, which is normally about 7 days. If a fraud proof is being generated, your transaction is being revoked. If it is not being validated, then it's being taken as a valid transaction. But by default, every transaction is valid in an optimistic rollup. And as the name implies, optimistic simply means it is always optimistic, right? So when you say someone is optimistic, they mean everything is yes, yes. The person is always, it's always yes for something. Yeah, that's just a simple explanation about optimistic. So how about validity rollups? So validity rollups, on the other hand, require the operator to submit a that attests to the validity of every transaction in the batch, along with the batch itself. So first and foremost, optimistic rollup, like I explained, they work with fraud proof, right? But with validity rollup, it works with mathematical computation. So in this case, we don't need to wait for anyone to validate that, hey, this is not a valid transaction. We don't need to wait for anyone. We use mathematics to be sure that it is valid. So now, instead of you waiting for fraud proofs or you using mathematics, which one is better? Let's take consensus from us now. So do you trust mathematics or do you trust dispute resolution? I think the first one is just more of prevention or drinking Panadol after the headache. And then the second one is more of prevention, is better than cure. So instead of you trying to cure it, you prevent it first before you cure. Or you prevent it first and then you even avoid curing at all. All right. So in this case, validity rollup take roughly about just 3 to 7 hours for your transactions to get settled on layer 1, right? 3 to 7 hours. So which do you prefer to? Another question. Will you prefer 7 hours or 7 days? Or will you prefer 3 hours or 7 days? Which one? The ball is in your court, right? But StarkNet is a validity rollup, just so you know, meaning it works with mathematics. It works with mathematics to verify transactions. It's faster, blah, 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 and the rest. So let's proceed. So smart wallets now. So, you know, I told you guys every account on the StarkNet blockchain is a smart account, right? So let's understand what they are now properly. So what are smart wallets? So it's a wallet that allows you to sign transaction with either your touch ID, your face ID. It can execute multiple operations in a single transaction. And then on every wallet is a smart wallet. There are no EOAs. They are built using account abstraction. And then all these wallets are just code that exists on the blockchain, right? All my long explanation, that's where it ends. Not EOAs. So they don't have private keys. They are codes. But that doesn't mean they don't have private keys, because you will certainly see private keys in your system, but just know that your wallets are codes that exist. So now, 2 things you need to know: signers and account. So in smart wallets implements these 2 things. First and foremost, it needs a signer and you also have an account. So in your normal EOAs, they only work with the account itself. So you will be the guy that signed the transaction. But with the signer can be a device that signs the particular transaction, or the signer can be the user who is identified with the private key. Oh my God. So the signer can also be the guy who is identified with the private key. Let me take a second, guys. All right, so next is the account. So the accounts are smart contracts on StarkNet. They hold the assets, they verify transactions, they execute the transactions with multi-core or with normal cores, right? So these are just the 2 that exist. All right, so because of this class, we are going to have a very short exercise. So for this exercise, you guys are going to be installing either the Bravos or the Agent Wallet extension. Next, you are going to try to create an account on Sepolia, and then you try to fund your wallet with a faucet. Then we can be able to proceed with the class. So with this, after that, we try to run a transaction, check the transaction lifecycle, deploy an account, etc. So that's what we are going to be doing.
So please, which one is best? Is it Bravos or Agents?
You are come out talk from my mouth. Install the two. Okay. So I'm going to give you guys just 5 minutes for this. Then we'll be back and then I'll proceed. So or use it on your or install the mobile apps, right? So in case you are done, just like raise up your hands so that I will know the amount of people that have done already. So to know when to proceed.
Sorry, sir, I have a question.
Yeah, shoot.
Yeah, sorry, I had to stand up to do something important. I just came back. Are we supposed to do it in our phones, on or on our system?
Yeah, so because you're a dev now, I would say you do it on your laptop. So install the extensions, but you can
Okay,
also do it on your phone. They are all the same thing. So in case you can't do it on your system now, just do it on your phone. It's still fine.
okay. Let me do that now. Thank you.
Cool. So don't forget to raise up your hands, right? So that I'll be seeing the numbers of people who are done.
So it's like StarkNet doesn't give it seed phrase.
Yeah, which one? Agent.
The agent, Bravo, so I've not really seen any seed phrase.
Oh, okay, okay, okay. Yeah, but they are supposed to give you. I think it just signs you up first. Within the wallet, you can be able to take it.
Okay.
Okay, we only have two people for now. Against about so let's see when we have five, then we'll proceed.
I'm at the place where it's telling me to choose my account. I'm choosing it, but it seems not to be clicking. I don't know why.
That's serious. Is it urgent?
Yes, it's agents I went with.
Let's take it slow. Let's take it slow. Or try Bravos, then you come back to urgent again.
Okay.
Now we have three people. Two more to go. All right, one more person and we'll get started or continue. Okay, guys, so I'll be sending a link to the chat. I want you guys to go and collect test tokens there. So you can just go and paste any of your address, either your Bravos or uh, this thing address, agent. Remember, it should be Sepolia. Don't go and paste your mainnet. Post the Sepolia address. Make sure you are on Sepolia. Then copy the address for Sepolia and then collect testnet tokens with it. So as soon as you collect tokens, you can send your transaction hash here so that we can verify. Then we proceed. So those of you who have installed, just do that ASAP. Let's proceed. All right, guys. So let's proceed. I guess you all have gone through the installation. I have set up your wallets and then I've received test faucets. Okay. Sorry. All right, so let's just check this out. This is my main net. Let me switch to test. All right, well, let me collect test tokens here. Then I'll copy the transaction hash and then let's take a look at the transaction life cycle. So what happens behind the scene? And then we proceed to StarkNet's architecture. So what we're explaining now will be needed also StarkNet's architecture. So let me collect stack. Don't know what's happening. My network is lagging a bit. Let me just do some refreshing and then hope I'm still on the call. I've not been lost. All right. Yeah, so I lost my network for like a second, but I think I'm back on track now. So let me just refresh this faucet page. We are good to go. All right. Or better still, let's just do some sending from one account to another since this is fucking up. So let me just copy my account too and then send some stack. So forget it's showing 0 here. I have stack and also ETH here. So let me send this 20 stack to my account too. And then copy the transaction hash. Then we look at the life cycle. To go back, you can mute your mic. So you can see how low transactions are, right? Oh my God. Can someone help me mute him, please? Fighting. So you can see how low transaction is. The estimated fee is about 0.000039 stack, which is very, very less than $1, like very less. It should be about some 0.0 something dollars, so 0.000. All right, so let me just confirm that. So some people will say, Malo said this thing is fast, but why is it a bit slow now? I think it's simply because this is a test network. So the test network is mostly slower because what's the essence of a mainnet if the test net is fast? Everybody will just deploy on test nets. Let me try again. I think I delayed before I signed that transaction. Yeah. Send 20 stack to account 2. Yep. It's taking long. Is this still my network? My network is messed up. Thank God it hasn't even kicked me out of the call yet. All right, let me reject this, close the agents, then open it again, and then try to send. $20. Oh, bravos. Since adjectives. Let's switch. Let's switch to a test account. Right, so we have very small stack here. Let me check the account one if he has plenty stack. Okay, let's say we have like 4 here. Let's just try to do the moving around here. So let's transfer to this guy. Let's transfer to stack, and that's to my agent wallet, and then trigger the transfer. Now let's view this transaction on the Explorer. Okay. Now this is it. This is the transaction lifecycle on StarkNet. And then it went between all these stages. So first and foremost, it went from not received to accepted to accepted, sorry, to received, and then pending, accepted on L2, etc. So that's just what's happening. Then lastly, we have accepted on L1. So remember I told you guys these transactions, after they are being executed on the layer 1, they still get batched and get sent to the layer 2. And then in the layer 2 is where it gets settled on because of security, right? So in this case, these transactions have all gone through and has been accepted on L1. But because this is a validity roll-up, it needs some time for this mathematical proof to get validated and added to layer 1. So it is not yet added to layer 1 now. That's why you are seeing this accepted to L1 not showing green, sorry. And then this can take us approximately about how many minutes, let's see, or how many hours for this to go through. I think it should be reaching somewhere around. Or is it because this is loading? From the whole green, I'm supposed to see it on the tooltip. Let me refresh again. All right, as you can see, this is even much more slower. I see this will take roughly about 58 minutes for this to get verified. So that's even less than an hour for you to get accepted on L1. While in a normal validity roll-up or a normal optimistic roll-up, it can take about how many minutes? It can take roughly 7 days. If there's no fraud proof, then it's going to get accepted. So you can see this is just a simple transaction lifecycle on StarkNet. So how your transactions move is first and foremost, we are going to see it within the architecture. So let's head back to this and then check out StarkNet. Good. So this is what StarkNet architecture. Good. So this is what StarkNet architecture looks like. So first and foremost, we write our code or our Cairo program on our laptop, and then it compiles to Sierra. Sierra stands for Safe Intermediate Representation. It was introduced in the newer version of Cairo. I will explain why it was introduced. So after it gets compiled to Sierra, it then moves. It is from Sierra now. Your supercomputer is going to accept it, which is the compiler, and then it's going to get compiled down to CASM. CASM stands for Cairo Assembly, which is like the lower level of Cairo that the computer understands or the machine understands. So if you have done Rust, you will know of WASM, which is web assembly, right? Which does like almost the same thing as CASM. And then it's CASM that get runs inside of the Cairo VM, and then this trace is being executed. This trace is being generated, or the trace is being generated from the prover, and then it gets sent to the verifier on the layer one, which it returns two things: the result, it gives the result back to the user, and then it sends the validity proof to the verifier on the L1, so that it is going to compute the proof to be sure that everything went well. So this is just a simple architecture of Cairo. So in Cairo, it goes between short processes from the sequencer first and foremost. So your sequencer accepts your transactions. From the sequencer bundle those transactions together, send them to the prover. The prover is going to prove that, hey, all of these transactions existed on L1, L2, and all of them were computed correctly and they are all valid. Then it sends the result and the validity proof to the result to the user, and then the validity proof to the L1 for computation to be sure that everything went well. So these just the steps from compiling, sense here, it compiles down to CASM, you run it in the Cairo VM. After you run it, it generates a proof in the trace. So that's the trace here. This is the proof, also called the trace. Sent to the prover, then the prover sends to the verifier the validity proof to be sure that everything went fine, and then it sends the result to the user, and we are good to go. So in Cairo now, in StarkNet, here is how you deploy and declaring and deploying smart contracts. So those of you who have built on other blockchains, mostly you will just deploy directly. But in Cairo, you first have to, or in StarkNet, you first have to declare before you deploy. Okay, so declaring is a method that helps with declaring a smart contract registers its codes on StarkNet. That's just what declaring does. So it registers the code and then gives you a class hash. So a class hash is just a hash that links to the code base on the blockchain. So that if somebody is trying to deploy or trying to write the same type of smart contract, it doesn't have to go through the stress of writing the code. All you just have to do is get your class hash, and you can also deploy an instance of that smart contract. So first you declare before deploying. Declare, register it on the code. Yeah, Bed question. Or let me finish explaining. Just write down your question, then I will explain your question at the end. Thank you. So a declared smart contract is known as a contract class. So a contract class is ID'd by its class hash. So it's a class hash that is used as the ID to be able to find the contract class. So the classes are pure code, not storage at all. That's the class. So the contract instances can be derived from a contract class, like in OOP. So if you're, like I explained, if you want to deploy another instance of the smart contract, the person doesn't have to write the code. If it's the same logic, like take for example, you are building ERC20 token. You know, it's the same code now that you still write because it's the same standard you are following. So instead of you writing that code over and over again, you can just write that code once, declare the contract, you get the class hash, and with that class hash, you can continue deploying the instances of different ERC20 contracts. So a contract instance has storage. Okay, to go better, I think let me just take your question. So the question is, class has like interface of the contract? No, it's not like the interface. Yeah, I think what looks more like interface in Cairo is the traits, which you understand when you are writing the contract. So that will be like in the next 2 sessions. So 2, can other contracts communicate in our contract with the class hash? So the class hash only contains is just like the ID to the contract class, and then the contract class contains like the code. So this is just the implementation that we are talking about, the logic. This one doesn't even have to do with the storage. So for contracts to interact, it needs to interact with our smart contract. It can't interact with the class hash. So in short terms, Cairo helps for provable programming. It's a provable programming language. The syntax is similar to ROS. It compiles to Sierra, which is safe intermediate representation. And then this is just the layer that handles failed transactions in StarkNet. Then sequencers compile Sierra to save Kazim, which is the Cairo assembly. Failed transactions are included in blocks with the help of Sierra. Then sequencers are always compensated, just like how validators are compensated in Ethereum, right? Or in the EVM. And then no DOS vector. So, so we have come to the end of today's class. So you can study more about this. You can check out the Cairo book, which is like the main book that can help out. So I will just send a link to that in this chat. So this is it. Let me just copy it and send it in the chat. Where's the chat? Here. You can also check out the StarkNet book also, where you can learn about StarkNet. So for the documentation, it can also lead you to the book. So you can start with these 2 main resources, gradually start learning about Cairo, and in no time, you will be good to go, trust me. All right, so enough of me. I think I've spoken a lot for today. Let me use this opportunity to take questions, and then we should be out of here for today. So questions, guys. Questions. If there are none, I will not force you. I will even be more than happy because I'm exhausted. But I would really love to take questions to be sure that you guys followed, and then if there are any confusions, I can clear them out. But if the class is well understood, you can continue with the resources. Then always you can reach out to me on my Twitter. I will be always available to answer your questions.
So please, I want to ask one question. Is like, should I say, is StarkNet specifically built only on that Cairo? Because when talking about other languages, they don't talk much about StarkNet. When it comes to StarkNet was being mentioned consecutively.
Yes, Yes, actually. So Cairo was built for the language, but it's built for the long term. So they didn't make it like just for only them alone. You can use it subsequently for other stuffs. But for now, when you want to build on StarkNet, you need Cairo. I think there's another new language, no lang. That one is like bobbing up now. That can help you generate stack proof also. Yeah, so I think that's another one. You can also check Neolang, but I haven't tried to write smart contracts with them, so I can't say much about them for now. But for now, Cairo is a language for building on StarkNet. Questions? All right. So since there are no questions, I will call it a day. You guys should feel free to come to my DM, message anytime. Okay. Usman Emmanuel.
Well, good evening, sir.
Yeah.
So I was going through the documentations, and when I checked the installation of the compiler, I was seeing only Mac OS and Linux. Does it mean Windows cannot work?
Yeah, to be honest, I really don't know anyone who builds on StarkNet that uses Windows, except with WSL. So if you are still working with Windows, I would say it's safe to just leave Windows for now.
All right, sir. Thank you, sir.
Cool.
So I want to ask another question. Kind of when
Yeah.
compared with Rust, does it deal with garbage collector for reference?
Yeah, so it's the same model it works like with Rust, ownership instead of so Rust work with like a memory model, right?
Yes.
Yeah, so it doesn't work with garbage collectors actually. So that's the same thing with Cairo. They don't work with garbage collectors. They just work with ownership. Uh, and then memory management is handled by you, the dev. All right. Any more? All right, guys. So see you guys subsequently. I'm out for now. Enjoy yourself.